I get the volleyball part, but I didn't know that meant she wasn't at school either.
Yeah.
Okay, combining the exponent laws. Here it goes. It says 3 students are attempting to simplify the following expression: 3x squared times 5x cubed. There are their answers, Harry, Janet, and Laura. Which one is correct? Go, quick. Which one's right? Go, Mackenzie. Laura. Well, Harry's definitely not right because he did not multiply the 5 and the 3 he added. So forget him. How about Janet? How come you didn't choose Janet? What did she do wrong then? Oh, she multiplied the exponents. Remember when they each have their own base, right? They each have their own base. So there are 2 x's to be shown. When they each have their own base, then we say, well, if those 2 bases are the same, when there are 2 bases, and you're multiplying, you keep that 1 and add the exponents. Remember that? So yes, Laura is the same. Laura is correct. Okay, part 2. Is 6a to the 6 divided by 3a to the squared, is that 2a to the 4th? Is that correct? We're supposed to use factors to explain it. Okay, watch this. Do you agree that this would be like this? Yeah? Okay, so to use factors to explain it, they want us to break that all up, the top and the bottom, into their factors, which means they're what? What are factors? Pieces that multiply together. Okay, so let's get some pieces that are multiplying together here. So I would say this is 2, and this is times 3 times a times a times a. Smaller. 1, 2, 3, 4, 5, 6. Okay, and the bottom is 3a. You with me? Now, there are no other factors than 3. Just 1, I'll just go with a 3. So it wants us to figure out what these would be. Well, this is where you go and divide and conquer, right? Yeah. So this 3 over 3, that's a big 1. There's another 1. There's lots of them. So 2 times 1 times 1 times 1 times 1 times 1 times a times a times a is 2a to the 3rd. All in favor, say aye. Aye. Really? You worked in favor, Maya? Okay. All right. Could we have gotten there without breaking it all up into pieces? Could have just done 6 divided by 3. Get your answer. I have a problem. There's a big problem. Wrong. There's only a squared on the bottom, right? I put a cubed because a squared on the bottom. That's better. So it should be 2a to the 4. Now does that match? And the rule would be if there's 2 bases and the bases are the same and you're divided, you keep the base, subtract the exponent. So the 6 take away 2 gives you the 4. We already knew that. Let's move on. All right. Let's go fast. I should have done this homework yesterday. Okay. As quick as you can, tell me A. Right now, go. I need speed, people. Hannah, what's the answer to A?
8x 8.
Okay, I'm just going to call names. Jonah, what's the answer to B? 6 times 7? Yes. 42? 42? Negative 42 what?
20.
Excellent. Okay. Who's back there? Sophie, what about C?
4
Y to the 15? Yes. Okay, D. Adrian, D.
2 over 3, B.
2 over 3. And then B to the 4 is on the top. Do you agree that B to the 4 is on the top? It's got to be on the top because there's 14 B's written out in a row. We've got to think about that. B, 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 right? Then there's only 10 B's in the bottom. B, 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 B. Stop. Okay, then they all cancel, and you have B to the 4 left on the top. You with me? Okay, where did the 2/3 come from? Well, 15. People, that's on a clock. 30, 45. Think about on a clock. 30 minutes, 45 minutes. 15 goes into both those twice and 3 times. Done deal. Okay, let's go here. Letter E. I don't care. Ashlyn? 5, 6, 7, 8, 12. Yep, good to go. And F, Bailey.
8 and 4.
Excellent work. Okay, go on. Simplify the following. Well, what happens if they're not together like that? Is that all right? It's okay. Any order doesn't matter. So I can rewrite that if I had to, but I can just put this x to the 5 with this x to the 3 and get x to the 8. And the y's together, like y to the 8, y to the 4 is y to the 12. You're allowed to do that. Did you know that? You can. You put the x's and do what you need to do with the x's. Okay. On B, I'm going to do the same thing. X's with x's. It's x to the 2, and y's with y's. Y to the 4. I'm dividing, so I'm subtracting, because if I have two bases and the bases are the same, keep the bases, subtract the exponents if you're dividing, right? Logan, you hanging on? Hanging in? All right, C, go Logan. What number would I put down as the answer for C?
So 12.
12, excellent. And then B to the what?
6.
Yes, sir. C to the
5. Or 4.
You sure? It's 4? Yeah, because you're right. This is a 1 and this is a 1, so we do get a 4. So if exponent laws are new to you, remember that if the C or the letter, the variable, does not have an exponent on it, there's a 1 there, right? Don't forget. Okay, how about D? Ashlyn.
E to 4. F5. 5.
Sorry, I didn't hear you. What?
5.
Good. Okay. It's all reviewed. Do a little bit more. Let's just do, I'll do 2 of class example number 3, because we know how to do this, right? Just lots of simplifying. So give me 2. Which 2 do you want to do on class example 3? Go, Mackenzie, choose. B. Oh, C. Okay, let's do C. Oh, all those x's. You know what I would do first? I would do x to the 8 over x to the 3rd first. I would do a little squishing together of the top and the bottom, make it simpler. And then go ahead and do, okay, if the base is the same and you're dividing, keep the base and you subtract the exponents. But I would do that little simplification step first. I just think it makes, I try to give you ways that you make fewer mistakes, okay? Lots of ways to do something, but some ways will help you make fewer mistakes. Okay, so let's do D while we're at it. I'm gonna cube the negative. I'm gonna cube the 2 and cube the A and cube the Y cubed. What's the cubed Y cubed? 9, Y to the 9. So we're gonna times those together because that's a power of a power, which is a superpower. Good, okay, go on. I'm going pretty fast. It's mostly review, right? I don't know how you feel. You feel okay? Drowning, slow down. Throw me a life jacket and Dwayne the bathtub. Knock, knock.
Who's there?
Dwayne the bathtub. I'm drowning.
What? Oh.
Oh, it's good. So good. I mean, you didn't even laugh. I'm so offended. Okay, no. All right. Which one of these do you want to do? Should we do them all? Jonah, what do you think? What if you were the teacher? What would you choose to do? Be the teacher.
I don't know. Do whatever the kids want to do.
Oh, so what do you want to do, Jonah? Teacher and the kid. Okay, let's do them all. Okay, so what's important about this one, of course, is the sign. All right. So what is this 2 of, does that 2 belong, does it affect either of the negative signs? The little 2 on the end? Nope. It doesn't affect the front sign, it doesn't affect the sign in front of the end because there are no brackets around separating the 2 from the negative end. Okay, here's what you would have to have something that, if it was like this, now the 2 affects the negative in front of the end, but it isn't there. So it doesn't affect that negative. Does the 5 affect a negative sign? The inside or the outside or both? Which one does the 5 affect? The inside. Okay. So let's just copy this guy down. Just write him down. Because nothing is affecting him. You tell me that nothing affects him. And now let's apply this outside 5 to this negative sign. What would we get? A negative. But the 5 also applies to that, so we get n to the power of a power 10. So all said and done, you have a positive n to the 10. Good thing we worked on that one. Because the opposite of an opposite is positive, right? Okay, let's do B. There are 2 options on B. You can apply the 4 to everything right now, or you can simplify what's on the inside first and then apply the 4. What do you want to do? Simplify the inside, because that's what God does with you. He works on your inside out. This is like preaching a sermon. Okay, he does. He works on your inside first. And that eventually changes how your outside goes. So let's work on the inside. Now, not always, people. I won't say this is always the way to do it, but it's pretty much. It's a good method. Okay, so I'm going to do the top first. 4 times 3 is 12. I'm going to copy down. I'm going to put them in alphabetical order. I just like to be like methodical. I like my things in alphabetical order, so be that way, right? Okay, copy the brackets and put the 4 up there because I haven't dealt with it yet. If you haven't done anything with it, copy it down. Okay, I just smushed stuff together. Okay, now again, could I simplify further on the inside? Sure you could. See that 12 over that 6? We've been doing 12 over 6 for a long time. 2. So let's turn this into a 2. How about those X's? I can sing again. All my X's live in Texas. Okay, Texas is the place I really love to be. Oh, George Strait for you. Okay, and then I put the brackets down, and then I put the 4th on it because I haven't still dealt with that yet. Right? If you haven't dealt with it, write it down. Okay. Now I've got nothing left to do but apply that 4 to everything inside the bracket. So 2 to the 4. 16. X to the 4. Y to the 3rd to the 4. Ooh, Nelly, there you go. Right? All good. Whew. Do you see all the places you could have made a mistake if you weren't careful? This is like, okay, sometimes mistakes are okay. When you're painting the fence, you just go back and paint it again, right? But when you're doing surgery, it's not so good, right? So sometimes you have to be sciences, okay? If you put the wrong things together in an experiment, you blow the whole building up, right? Like some things, it doesn't really matter what you're doing. Cut the grass, no worries, just do it again, right? But when you're doing scientific things, we have to be careful. You have to be careful. So be careful. All right, C. Let's do C. Okay. Gotta keep me entertained. Yeah. Okay. Any ideas of what to do first here? Okay, here's my question. Is there anything inside the bracket to simplify? I guess that's what would be my question. Like the X cubed and the Y 5. Can that get anything smaller than that? No. Can the 2X squared, can anything be done there? No. So there is no inside to do. Do you know what I'm saying? Versus over here. Okay, see the difference? So since the inside can't really be helped, I would probably just start applying that outside. I would apply these outside things first. So the difficulty with exponents is this very fact that what you might do and what I might do might be totally different, but we'll arrange to arrive at the same spot. So some kids have a really hard time with that flexibility. They just want it to be one way, right? Just do it this every time, do this. Except it's not like that in exponents. Does this too, right here, apply to, what does it apply to? Come on, not done. All right, Hannah, what does it apply to? I'll ask you names. The little 2 on the top, what does it apply to? What does it apply? What does it affect?
All of them.
What do you mean all of them?
All of what's on the top.
So the 16?
Yes. No. Yes.
Why not, Summer? Right. The 16 is not in the bracket, so you're right to question yourself. That was good. So we got 16 alone. He does not get affected by that 2. You see it? Because the brackets aren't around the 16. So now this becomes x to the 6, y to the 10 on the bottom. Does the 3, the little cube, affect the 2? Bailey?
Yeah.
Yes. Why? Because it's in the bracket. So 2 cubed is 8. X to the 6. See it? You gotta ask yourself, what's being affected here? All right, now the 16 over 8. We've been doing 16 over 8 since we were in grade 3. 2, 3, when did we learn that? 16 divided by 8 is a 2. X to the 6 over x to the 6 is a 1. And I get y10, all done deal. Not so bad. Okay. One more of those lessons over there on the D. Anything inside the bracket to actually simplify. Can I squish anything that's in the brackets already? Can I put them together? No, we can't really. So if you can't do with anything inside the brackets, let's apply this little guy first. He goes everywhere. So 25a squared b to the 12. Copy the brackets. I haven't done any multiplication between the brackets yet. Right, I'm just applying that squared inside there. I don't think I've made a mistake yet. Tell me if I do. Now we're going to multiply those 2 brackets together. Final answer, Micah?
100 a to the 4 b 13.
Excellent work. Okay, good. Google, Isaiah, how you doing back there? Did you know that was going to be the answer? Okay, next one. Here we go. Negative a to the 6 divided by negative a to the 4. What is the base of both of those terms? What is the base? Negative a. Are the bases the same? Yes, they're both in brackets. It's exactly the same. So if the bases are the same and we're dividing, we keep that base. So you better keep the base. Like you better write the base down, like what it was. Copy all of it. And we're going to do 6 take away 4 is 2, because what's the final answer then? A negative a quantity squared becomes a positive a squared. So if you had not written down the brackets, you would probably get it wrong, because you would have left your answer with a negative a squared, and it's not negative. Okay. Letter B, are the bases the same? No, a little kid can tell that's not the same, because there's those curvy lines that go like this on one side and they're not on the other. I mean, I don't care if you don't know what it is. Those are not the same. Okay, so let's see if we can figure out how to write it the same. I'm going to copy this negative a to the 6 down. I'm going to copy that down because I know how to copy. Now, negative a to the 4. What did we learn? Well, because the negative is inside the bracket, 4 applies to all of it. So you end up with a what? Positive a to the 4. Okay, all we have left now to think about. Now, do you have 2 bases that are the same? Hannah says yes. This little negative, he's just hanging around, and you know what this is. A negative divided by a positive is still a negative. Deal with him first. There are no brackets. And now just do a to the 6 divided by a to the 4 is a to the 2. Whew. All right. Same with letter C. The bases are not the same. One's got those curvy things around it and one doesn't. So no point trying. So let's go deal with the one that has the brackets on it first. Copy this guy down. Copy down your divide sign. What is negative a in brackets to the 3rd? Isaiah, do you know what negative a in brackets to the 3rd would be? Okay, now neither one have little curvy lines around them. So now the bases are the same, but do your signs first. So what's a negative divided by negative? Positive. And a to the 7 divided by a to the 3 is we're going to get a positive a to the 4. It's all about the signs, people. Here's the sign. Walk outside and see a guy trying to get his car unlocked. He's got a coat hanger. Here it is. Coating her down in his car, and you know what's gonna happen. Someone walks up and says, "Look, keys in the car." Nope. I washed it and I'm hanging it up to dry. Who knows? Anybody ever heard "here's your sign" jokes? No? You haven't heard them? Oh my goodness, they're so funny. It's the stupid questions people ask. The obvious questions, and people ask them all the time, right?
Oh,
So the guy buys a Christmas wreath and he walks outside and the guy's walking, he's like, "Oh, you bought yourself a Christmas wreath?" "Nope. Toilet seat cover." It's just like, of course it's a Christmas wreath, buddy. The guy gets, I've told you these before. Haven't I? Okay, the guy's going down the highway and there's like the traffic's just lined up. Just lined up for like a mile. When they finally get there, there's a semi, it's a true story. A semi had gotten his truck, like the overpass. He didn't read the signs about how tall it was, and sure enough, he drove his truck right under the overpass. And he's like, just waiting for the question. Just like, you know it's coming. Someone walks up and says, "Oh, you got your truck stuck?" "Nope, just hauling this overpass down the road." "Here's your son."
What?
People do it all the time. Just wait. Just listen for the questions people ask, and it's like, man, those are dumb questions.
I don't
Okay.
do that
All the time. Okay, the dumbest question your mother ever asked you? "Mom, I can't find that book." And the question is,
Where'd you put it last?
where did you put it last? Where did you last have it? Well, if I knew where I last had it, I would know where the book was, right? What?
Yeah, you still asked the question.
What we remember is, what we're trying to say is, where can you remember having it last?
That's the same thing.
No, it's not the same. So I can't find the keys. Well, here's what I know. I drove the truck home last night. I haven't been anywhere since then, so I either left them in the truck, I put them in my coat pocket, or they're in my purse, or I threw them on. They're in this house somewhere, right? Because I drove it last night, so I know they have to be here. So that's okay. Here's your sign. Here we go. Next question. This little 3 out here. Okay, I look at the brackets. If there are no A's, B's, or numbers to put together inside the bracket, then the next step I do is apply any outside exponents to that bracket. What I just said. Let's talk about that. If there's nothing inside the bracket to actually smush together, then I start looking at these guys out here. Okay, that little 3 applies to everything inside the bracket. So a -2 cubed is a -8. A squared cubed, A to the 6. B cubed cubed, B9. Okay, copy. You haven't done anything with it, copy it down. Now, the object of this game is to multiply that all together. So -8 times 4 is -32. A to the, I'm going 11, and B 16, because they are individual bases. And if the, question me? And if the bases are the same, I'm going to keep the base and add the exponents together. All in favor? Okay, one more, and then I think I'm done. Am I done yet? This is a long lesson. Oh, yes, I'm done. Okay, so now here again, I'm looking for brackets. I'm looking inside the brackets. There doesn't appear to be anything to do inside the brackets. There's an option. You could deal with the 72 and the 6 right off the bat. Anybody want to do that? You could. Let's do it. See the 72 and this 6. Now do not go anything with that 2, because that's not really a 2. What is that number really going to be? Say it louder. An 8. So don't get yourself looking at that 2. It's in a bracket. Leave it separate. I'm just going to worry about this 72 and this 6, because they are not affected by any exponents. There are no brackets. What's 72 over 6? 12. Okay, so I'm going to copy this down. I'm going to write a 12 here and just like be done with those. That's a 12. I'm going to copy the x4, y10. Now you have to be super organized right here. Like, be methodical. Do not leave the scissors in the guy's belly when you're doing surgery. That would not be good, right? It's happened. They leave tools inside of people. Okay, now, the negative z squared to the fourth power. What? Because we're being methodical, we're doing surgery.
What happens though? It happens.
It happens,
Yeah.
see? People aren't careful
People get sued all the time.
all the time. Somebody left it voted something. I think it's a lie. That's the only other commercial, right? If you go commercial with the guy's phone starts to ring with these. Where's my phone? Just a commercial. Okay. Now, okay, we gotta come back. Okay, come on. I don't know. Okay, so I make them up. Okay, x to the 3, y to the 6. Oh, come on, follow. Keep going. Z to the 8, y to the 3. Can you very carefully make your z look funky somehow so it does not look like a 2? Okay, I put a little line across mine just to clarify that's a Z. They look like 2s if you don't write it careful. And I have had people that couldn't read their own writing and they get stuff wrong. Okay, I think that's all good. I think everything out there. I applied this little 3 guy to both of these, all of those objects right there. That's where I got those x cubed by 6. Okay, almost done. 12 over 8, let's change him. Reducing down. So yeah, 4 goes into both. So 3 over 2, I'm gonna deal with that. Okay, let's go get all the x's. X to the 4 on the top, x to the 3 on the bottom. Divide and conquer. There's an extra x on the numerator. Right? Okay. How about the y's? I have y to the 10 on the top on the numerator. What do I have on the bottom? In the denominator, I have y to the what? 6 and 3. So can you think of that as a y to the 9? Can you please just imagine there's 9 y's lined up and y to the 10 on the top, and then they would all cancel and leave you a y on the numerator. And then the z to the 8, z to the 8, down 1. All good. Okay. Yes. Questions? Tons of good practice of all of those laws that you learned yesterday, right? Okay. Promise not to take you in any more rabbit trails. Except I will. Okay.